this is Terranova. It's a visualization based on the recent Perseverance mission in a crater called Jezero. So this is the visualization from the raw binary like grid data that was collected about the troughs, valleys, etc. And the key thing with this mission was that up till now, all NASA missions with the rovers were like hand joystick controlled. But obviously, the thing with that is that there's a lot of human delay. There's transmission delay between the rover and human collection, and there's human man hours that are spent optimizing the right path. So the second part of training robots in rough terrain is that the shortest paths are not always the best paths. So if you use algorithms like A-star or other decision finding algorithms, you often end up with those going over these hills or the rovers getting stuck in craters. So how do you fix that? So the approach we used is first we made a C++ physics engine, so then we can build sort of like a gym to train an RL model to find the best path that optimizes for fuel costs and energy usage through going from point A to point B. So this saves humans from mapping out tirelessly like the path for the rover to take, and it helps the rover take decisions on the fly, and to hopefully reduce accidents and save like the parts from going in valleys or being damaged. So here, if I run the planned run, you can see that the shortest path line, the pink line, is pretty straightforward. Or I'll show it over a hill. And if I pick both, yeah. So the pink line just goes over this hill. It's just straight, goes through the path. So if I drive it, the rover would have to climb this hill, which in a real case would not be the most optimal, and then it goes to the shortest path. Conversely, if we do the physics and energy optimized path and drive that, like a human would drive through a valley, it optimizes for fuel efficiency and pothole avoidance. So in each pick of this, it's trained on these parameters like fuel efficiency, pothole avoidance, and the RL model basically minimizes its loss by optimizing for the least slopes and avoiding potholes or big mountains. So this visualization helps us see the importance of using R-like techniques in building like gyms and like physics engines for different planets to see how rovers would act there. So yeah, that's Terranova, that's the project.